All right, this is lesson 1.1, interval in set notation. By this point, you should have a journal to take your notes in. Also, somewhere you should have either been handed or picked up this little half sheet with the circles on it. We're talking about different types of numbers. The first one that we have is right here in the middle. These are your natural numbers. Natural numbers are just your counting numbers. So keep in mind, we never start with 0. If I tell you to start counting, you just start with 1, 2, 3. Those are going to be your natural numbers. The next layer is your whole numbers. Whole numbers are your counting numbers, but they also include 0. The next layer out are the integers. So we never count with negative numbers. That's why our natural and whole numbers don't include negatives. However, integers do include your negative numbers. So integers, those are your counting numbers, so your positive numbers, your 0, and your negative numbers. So natural, that's our counting. Whole numbers, our counting numbers plus 0. Integers, that now includes our negative numbers. The last circle here is our rational numbers. Rational numbers are fractions. Ration means part of. So rational. This includes everything below it. So our integers, our whole numbers, our natural numbers, as well as fractions. Also, fractions are repeating decimals, so you can also put that in there. Fractions and repeating decimals are pretty much the same thing. Okay, on the other side of here, so we've got rational numbers, which we just talked about, and then we have irrational numbers. The only things in irrational numbers are going to be your non-repeating decimals, things such as pi. Pi goes on forever and ever, and none of it is repeating. Square roots, those can give you non-repeating decimals. This number here, 2.718 something, something, something. A non-repeating decimal that goes on forever. So that's what an irrational number is. Non-repeating decimal. So you want to grab a piece of, or not a piece, but a glue stick and glue this into your notes. You definitely don't want to be losing this. All right, using these, we're going to be talking about how we write sets of numbers or groups of numbers. There's a couple of different ways we can write it. If you'll notice on this chart that I gave you, the first way that we have listed is what's called interval notation. Interval notation can be written with parentheses or brackets depending on if we are including numbers or if we are not. So we use parentheses whenever the point is not included in the set. I'll show you an example of that. If we're going to graph it, we graph these numbers with an open dot. So numbers that are not included are graphed with an open dot. However, if the number is included in the set, we use brackets when the point is included in the set. And whenever we graph this, it's going to be shown by a closed dot on the graph. So what I'm talking about is, if you'll look at this graph over here, I know these numbers are very small. This, we're going to call it -4. You might want to write that in there. And this is +7. So the set of numbers that we're talking about here are all the numbers between -4 and 7. If you'll notice that the dots are open, so that means -4 and +7 are not included in the set. I'm talking about anything in between them, but not -4 and not +7. For example, a number that's in between here would be 6.999. That is included in the set. +7 is not. That means it is not included. So notation, the way we write this in interval notation is pretty simple. It's always going to be your smallest number, comma, your highest number. And then we'll use the parentheses or the brackets to show whether the points are included or not. If you'll notice how I wrote interval notation over here on the left, that gives you an idea of how it's supposed to be written. So the smallest number in this set, of course, is -4. The largest number is going to be 7. And then we just have to use parentheses or brackets to tell whether the point is included or not. Open dot means we use parentheses. Above the 7, there's also an open dot, so we'll need a parentheses behind the 7 as well. This is your interval notation. Another point to make is X is always the line, and that'll come in to play in just a second. Again, here's another example. Your X is always going to be the line. Now, if you'll notice, there's not exactly the smallest number. So we have to think to ourselves, this arrow means it goes on forever. So the smallest number in this set is actually -infinity. It never ever ends. It goes on and on until -infinity. That's your smallest number here. This set goes all the way up to, I think that's a -1. So the highest number in the set is -1. We'll need to put our parentheses or our brackets. Remember that you probably can't even tell me what -infinity is if I ask you for a specific number. So if you can't tell me what it is, that means there's no way we can include it. Infinities are never ever included. It will always have a parentheses. The -1, however, has a closed dot above it, and we used closed dots whenever the points are included. In this sense, we would make a bracket for interval notation. So you may want to put a little note somewhere. Infinity is never included. Okay, so parentheses and brackets, those are what we use when we're talking about interval notation. The next thing we have is what is called inequality notation. Your inequalities, those are your greater than, less than, greater than or equal to, less than or equal to signs. Those are things that you learned from Algebra 1. And we're going to use these to pretty much describe the group of numbers in a different way called inequality notation. So remember on this first example I told you that the line represents X. That becomes important when we're talking about inequality notation. So we'll have one line here, that's our X. And this is how I like to write our inequality notation. Again, our numbers here, this is -4 and this is +7. So we're going to do it similar to how we just did our interval notation. Your smallest number always comes first, and your bigger number comes second, and X is literally between -4 and +7, so I want you to write it there. Now we have to place our inequality signs. So here's X, and here's -4. So what we want to know is, in this case, is X greater than or less than -4? Surely you told me that all of these points are greater than -4. Greater means the alligator eats the bigger number, in this case, which is X. This is just greater than. The point is not included, so that is what we need. If the dot was closed, we would need greater than or equal to. We're going to need an inequality on this side of the X as well. Here's 7. The X's are all less than 7. Remember that the alligator eats the bigger number. Again, this point is open, so we just need a less than sign. This is inequality notation. Okay, here's a second example. Remember, your line is going to be x. And this time we have no smaller number. There is an infinity this way. With inequality notation, we don't ever write infinity. So in this case, it's going to look something like this. We have x and our number, which is -1. Your line, or your x's, are on all of the numbers that are less than -1. All of these numbers are less than -1. However, -1 this time is included, so it's got to be less than or equal to -1. So if you have an actual smaller number and a bigger number, two different numbers with x in between, that's how you want to write it. If there aren't two numbers, that's how you want to write it as well. You only put the number that's given to you. This works for inequality notation. The last form is set notation. Again, pay attention to how I wrote it. It includes these little, I don't know, pretty brackets. Includes these pretty brackets that we use. It is basically the same thing as inequality notation. However, we just make it pretty. So we'll start with the same things we did before. Again, if you can't see it, this is -4 and this is +7. So I want you to take a minute and pause this video and just write your inequality notation. Okay, remember we always write the smallest number first. Here's my line, which represents x. That goes literally in between -4 and +7. Your x is literally in between -4 and +7. We need to write our inequalities. So in terms of -4, all of our x's are greater than. The circle is open, so it's just greater than. In terms of 7, the x's, or all the numbers, are less than 7. And again, my circle is open, so it's just less than. That's your inequality notation. To make it set notation, we do what I call make it pretty. And you just write it like this. X in a line. This line means such that. X such that -4 is less than x is less than 7. And then you got to make your pretty brackets. So I know some of you are probably thinking, oh, I can't make those brackets. Don't worry, I didn't learn to make those brackets until I was at least 25. One of my students a few years back showed me an easy way to do it. You draw a forward S and then a backwards S. And if you need to do the other one, you draw the backwards S first and then the forward S. And that will get you your pretty brackets. Okay, the last example, we have already written our interval notation for that. I'm sorry, our inequality notation for it. So we can just go ahead and copy that down. X is less than or equal to -1. In order for it to be in set notation, we have to make it pretty, which means x such that, pretty bracket, pretty bracket. All right. Go ahead and glue this and your half sheet into your journal so that you'll have it. And we're going to flip on over to the next page and work some problems. Okay, we're going to start with interval notation. I'm going to write it as it looks in reality. So remember, this is the one with the parentheses and the brackets. Now to keep everything in order, let's do, remember that if we have greater than or less than signs, we're going to use parentheses. And when we graph it, we graph those with open dots. And then if we have greater than or equal to, I'm sorry, that's a less than, or greater than or equal to, we use brackets and we use closed dots. I have a little smiley face thing to help you remember that. So the first one, here's your smiley face. And for the second one, here's your smiley face. Okay, so here's your inequalities. If it's greater than or less than, we have an open dot and we use parentheses. Greater than or equal to, less than or equal to, we use closed dots and brackets. So keep these smiley faces handy. They'll help you to remember how to write interval notation. Here's example 1. So I'm going to give it to you in inequality notation. So -2 is less than or equal to x is less than or equal to 3. And the first thing we want to do is write that in interval notation. So we have for interval notation, remember we always write smallest number first.
Testing 1, 2.
Then the largest number. So we have those two numbers here in interval notation. So our smallest number is -2. Our largest number is +3. Now for interval notation, we're going to need our parentheses and our brackets. This is a less than or equal to sign. That tells me bracket. This is also a less than or equal to sign, which also tells me that the 3 will need a bracket. We're going to go ahead and graph this as well. Now, for your graph, you don't have to put all the numbers on there. I mean, you can. 2, 3. See, 0 goes right in the middle. 1, 2, 3. 1, 2, and -2. So again, you don't have to actually write the numbers on there. It just crowds up your graph. 0, 1, 2, 3. That's good enough. Okay, so remember with brackets and when we have the equal to sign, that means we use closed dots when we're graphing. So above the -2, I'll need a closed dot, and the 3 also a closed dot. Remember I told you that x represents the line. Here's your x. It is literally between -2 and +3. Your line goes literally between -2 and +3. Okay. Here's another example. This time we're going to do x is greater than -1. X is greater than -1. Now with this one, it may be easier for you to graph it first, so why don't we do that? Here's our graph. And this time there's only one number that's on the graph, so I always recommend putting 0 on the graph so you kind of know which way you're supposed to be facing, and then we just need -1. This is a greater than sign. Greater than signs for our graphing, we need open dots. So above the -1, I'll put an open dot. Greater than, we want our line to point towards the numbers that are greater than -1. Ask yourself which way this should be. Surely we know that 0 is greater than -1, so we want our arrow to face in this direction. Lastly, we need to write it in interval notation. So now we have a graph that we can help write that with. And remember, we write the smallest number first and then the largest. So on this set of numbers, the smallest number is -1. But there is no largest number because it keeps on going. Think to yourself, where is it going to? It's going to continue to go on and on until positive infinity. The largest number in this set is positive infinity. Remember that infinities are never included, so we know automatically I need a parentheses. And -1, if we look at our open circle, that corresponds to parentheses as well. So my -1 will need a parentheses too. I'm going to give you 2 more examples. I want you to try these on your own. X is less than or equal to 5. And 16 is less than x is less than or equal to 27. Pause this video and try these on your own. When you're finished, come back and see if you got them right. Okay. Okay, sometimes it makes it easier if you graph it first, just like we did with example 2. So I'm going to go ahead and graph this. Remember, I always need 0 on my graph so I know where I'm supposed to be headed. And then 5, remember this is a number line, 1, 2, 3, 4, 5. X is less than or equal to. Equal to means I need a closed dot above the 5. And it says less than. So I want my arrow pointing to the numbers that are less than 5, which is this way. Writing in interval notation, I need my smallest number first. Smallest number, it's going left forever. The smallest number is negative infinity. The largest number in this set, it goes all the way up to positive 5. Brackets and parentheses, infinities never ever included, so they'll always be parentheses. The 5 is got a closed dot, that means it is included. Included means bracket. Lastly, this one I have 2 numbers. It makes it a little bit easier to go straight into interval notation. Smallest number first, largest number. Less than is a parentheses. Less than or equal to, bracket. Graphing this guy. Let's see. Always like to have 0 on there. 0 all the way up. I'm just going to call this 16, and then it's got to go up to 27. I'm just going to call that 27. It doesn't really have to be that accurate. 16, it's got a less than sign. We already said that was a parentheses. That corresponds to an open dot, so I need an open dot above the 16. 27 has an equal to, so I will need a closed dot. Now look in here, the X is literally between 16 and 27. Remember, X is your line. It is literally between 16 and 27. Moving on to set notation. Remember, set notation, you got to make it pretty. X such that. Set notation. So I'm just writing it in this form to help you remember which one's which. Set notation, that's the pretty one. Example 5. So for example 5, the set notation, we want the whole numbers, 50 through 54. The whole numbers, 50 through 54. So it doesn't want all of the numbers from 50 through 54. So it does not include 50.5, 50.6. It only wants the whole numbers. And if you'll remember, whole numbers are your counting numbers and your zeros. So it's only talking about the counting numbers between 50 and 54. So remember, we have to do X such that we're literally going to list the numbers from 50 to 54. So we have 50, 51, 52, 53, 54. Now the reason that I didn't put an inequality in here is because this is saying every number between 16 and 27, even the decimals. However, this problem asked me about the whole numbers, not the decimals, so I have to actually list specifically which numbers it's talking about. Don't forget to make it pretty, and there you go. Okay, example 6 says the real numbers from 0 to 4. Real numbers. Are decimals real numbers? Of course they are. So real numbers is talking about every possible number between 0 and 4. In this case, we can't list every possible number. We would be starting with 0.1, 0.12, 0.13, on and on and on forever and ever. So that would take an eternity. So we want to use something like this that includes every single number. From 0 to 4. Smallest number first, x in the middle, positive 4. From 0 through 4. Does this include 0 and 4? From 0 through 4, I would say yes, that includes 0 and 4. This is set notation, so we have to make it pretty. Example 7. The real numbers greater than 5. Okay, so this is talking about every single possible number bigger than 5. So every single possible number is x, all of them greater than 5. Not equal to 5, greater than 5. Greater than 5. This is set notation. Make sure you make it pretty. Okay, last thing I want to do is show you examples of set notation and have you graph them. This is example 8. So we're going to start out with a problem, x such that 2 is less than x is less than or equal to 5. And we're going to graph this. So remember, all we really need to graph it is this inequality part. So we can put 0 on the graph because that's important. The smallest number is 2, which is going to be over here. See, that's 1, 2, 3, 4, 5. The 2 is less than. That corresponds to an open circle. The 5 is less than or equal to. That corresponds to a closed circle. Remember that your x is literally between 2 and 5. That means your line is literally between 2 and 5. If you see this written in words, the line between is going to be said as between. It could be and. And is a big one. If you see the word and, that means your line connects. That means your x is in the middle. Another word you may see that means the same thing, your x is in the middle, your line is between, is intersecting. Okay. Example 9. This one's a little bit different. Again, it's in set builder notation, so that means the pretty one. X is less than 0 or x is greater than 4. Okay. And again, we're going to graph this. So this time I want you to notice that this one had one x and one line. This one has two x's, so how many lines should it have? Hopefully you said it should have 2 lines. So we're going to need the 0 on the graph, and we're going to need the 4. We can go ahead and place our dots. This is a less than sign, so that would be an open dot. This is a greater than, open dot. Again, neither one of these have an equal to, so that means open dots. Now we have to think about this. This says x is less than 0. So at 0, we want our line going towards the numbers that are less than 0. The numbers that are less than 0 are to the left. For the second part, x is greater than 4. So at the 4, we want our arrow going towards the numbers that are greater than 4, which is to the right. So now we have our 2 lines. We've got our 2 x's and our 2 lines. Another way to remember this is this word or. Or means opposite. Or means opposite, meaning your arrows are going in opposite directions. Anytime you ever see the word or, your graph will look like this, with arrows going in opposite directions. If you ever see the word and, your graph is going to look like this, with one line in between. Keep in mind what I told you. If there's an X in between the numbers, there will be an X in between your numbers on your graph. If you have two X's, you're going to have two lines. Another word you might see that means that your graph will look like this is disjointed. Disjointed because they're not joined together. All right, last thing I want to share with you is how we would write this in interval notation, meaning the one with the parentheses and the brackets. Anytime you have an or statement, you'll always have two different ones, like I have here. This is inequality. Well, technically, it's set builder. And if we wanted to write it in interval notation, we would write an interval notation for this guy. So remember, the smallest number goes first. If you look at our graph, the smallest number here is negative infinity. It goes all the way to 0. That's our highest number. Infinity never is included, so it's always parentheses. Open dot means parentheses. Or, now we have to write an interval notation for the second set. Smallest number here is positive 4. This goes all the way to the right, which is towards positive infinity. That's the largest number on this set. The 4 has an open dot. It is not included. Positive infinity never is. Here's your interval notation, set builder notation in your graph. So if you ever have an or statement, you will always have two sets of information. You're always going to have two X's